Hello, everybody. I'm Matt from VeloDB, and I am also a PMC member of Apache Doris. My topic is the fastest analytics and search database in the AI area. Uh, Doris is accelerating since last year, and we have published the fourth version of Apache Doris. In this version, there are more than 9,000 pull requests has been merged. It is really a big number. And also there are more than 300 features or improvements in this version. More than 200 contributors has contributed to this version. In this version, we mainly improved uh, many categories. For example, the vector search for text search and a synchronized materials review. And we also optimize the performance of our lakehouse query engine. We also do some compatible tasks to MySQL or Snowflake. And we have enhanced our search capabilities. We integrate many tokenizers in this version. Today, I will introduce the fourth version of Apache Doris in these three categories. First, let's look at the AI category. In this version, we have integrated some AA method to do vector search. We use HNSW algorithm, and the vector is present as an array or float. And there are many distance calculation methods, L1, L2 cosine, and product. And as we know, vector index may occupy many memory in our machine. So we also introduced many quantization methods, for example, SQ4, SQ8, and PQ. Currently, our vector search can support uh, two scenarios. For example, the first one is top inquiry, and the second one is range query. When we use quantization, we can find, for example, we use a 10 million benchmark. Every vector has about more than 700 dimensions. We reduced the storage from 31 gigabytes to 9 gigabytes. It really reduced a lot. And also we find the QPS of Apache Doris from 3,340 to reduced to 3,188. It's a very small decrease. And the recall rate from 91% to 88%. And this benchmark is run a very small machine. This machine has 32 CPU cores and 64 gigabytes memory, and we start about 240 clients to send the query concurrently to this Doris cluster, and the average latency is about 70 milliseconds. And we can find Doris can really support very large QPS and has very low latency and can support many vector search scenarios. Doris has support inverted index since the second version. We use inverted index to do equality and set comparison, the larger than or larger equal than comparison, and is not comparison. All these comparisons is equal comparison. We do not have some thing like to do neither, so we can do not do something like that the score. In this version, we introduced the tokenizer, for example, the Akin analyzer, JBA analyzer, PIN analyzer, and ICU tokenizer. For example, if we use ICU analyzer or tokenizer, we can support many small language. For example, Chinese and English and Germany. And we also support some mesh operators like that in Elasticsearch. For example, mesh any, mesh freeze, mesh all. And since we all know there are many users that they want to migrate from Elasticsearch or Solr to Apache Doris, the first difficulty have met is that they use something like Lucid's DSL to query Elasticsearch, but it is not provided in Apache Doris before. In this version, we add the support. We use a search function. In this function, user can fulfill the search function's first argument with Lucine's DSL. Uh, Besides the search syntax, we also support BM25 score algorithm. In, in this algorithm, we will collect some statistics about the docs and the term frequencies in tablet level. And when we do query, and we will scan one segment and when we scan one segment, we will using the tablet's global statistics to do BM25 score. And after the first stage, in the second stage is a global stage. We collect all the scores from different segments and do a global sort to get the top key records. We have support match any, match all, match freeze prefix, and search function. In these five functions, we have score capability. For example, we can use a simple SQL like this to do match any and then using the score as relevance result. Besides vector search and fault search, Doris originally supports SQL search, and we have ability to combine these three search availabilities into a simple circle. For example, using this simple circle, you can use update time to do some accurate filters to filter the data using the date field. And we can use the description field to do some mesh filter. And finally, we can use a cosine instant distance to do some vector search. In this version, we also add more than 10 AI functions. Using these AI functions, we can collaborate with the LL models more easily. For example, we can take a look at the left SQL. The first SQL we create a table. The table saves information about the job requirements, and the second table we save information about the candidate profiles. And the third SQL, we can use a LM filter. No, it is renamed to AI filter to combine these two information and submit this information to the LM models and to filter whether the candidate profile is meet with the job's requirements. So I think it is very easily and also there are many other AI functions you can search it at Apache Doris website. The third part of our AI availability is our MCP server. We use MCP server to export Doris the metadata and some query plan and auto log to the AI agents. And also, Doris is also a lakehouse query engine. We can the AI application layer could connect with Apache Doris MCP server and send their circle to Apache Doris, and Apache Doris can connect with MySQL, PostgreSQL, and ClickHouse, even a file or packet file S3 or HDFS. So when you use Apache Doris and the MCP server and the database, your AI becomes very simple. The second part I want to introduce is our performance. Our performance becomes more faster. The first one I want to introduce ARM. And as we know, sometimes we see the price of ARM CPU is a bit lower than x86, the price. We have optimized our performance on ARM platform. We using ARM's new or SVE instruction set to optimize our performance for some operators or string functions. After that, we have tested our new version on many benchmarks. For example, ClickBench, SB or SB flat, TBCH, and TBCDS. We can find in this table almost all these 5 benchmarks. On ARM platform, we can gain about more than 40% improvements. Uh, and this benchmark is tested on AWS Gravity 4 architecture. The second optimization is top-N. Top-N is used in many scenarios. For example, in a log search scenario, we always search log by using the timestamp and order by timestamp with a limit in clause. And also in some tools, in some database management tools, for example, DeepEver, an end user will to try to sample the data using top-N query. For example, select from the table, order by some column and the limit 100 or 200 to get the data, get some data. For example, in the left circle, we can assume that this big table, for example, has 100 columns, and we order by the result by using key column 1 and key column 2 and decreasing. In the past, if we want to order by the column 1, column 2, even though we only order by column 1, column 2, but we have to read the total 100 columns into our memory, and then order by these two columns and return the end records. In this case, we can find we read many useless columns because we only need column 1, column 2 or to do sort work. We do not need any other 98 columns, but these columns also read it. It causes many IO operations, and also we need to shuffle the data across different machines because Doris use MPP architecture. And also, if we want to do order or sort work, then all the data is saved in memory. The memory may be not very enough, so it also costs a lot of other resources, for example, CPU, memory, and network. In this version, we optimized this scenario. We split this circle into two stages. In the first stage, the query engine only read column 1 and column 2 and do some sort work. And then before return the result to the user or to the client, we send another RPC to our table. We call the second stage to read the other 98 columns. So this really reduced many IO and reduced the CPU, memory, and network usage. In our benchmark, we use TPCH, 1 terabyte benchmark. We find many queries has 10 times faster. And the next one I want to introduce the performance improvement is about our synchronized materials view. In this version, we have migrated our synchronized materials view mechanism to external table. You can build a materialized view on top of iceberg catalog or iceberg table, and then we save the materials view into Doris internal table. After we build the materials view, we can find in some tests we get for more than 42 times faster, and the average latency is reduced to 23 milliseconds. Is really very fast. And also we support more than 5 times concurrency. The next one is real-time update and query. Real-time update is really very important because I found in many scenarios, users want to synchronize their data in MySQL or PostgreSQL into Apache Doris and to do analytics work. Because there are many updates in PostgreSQL or MySQL, Doris has to handle this update very quickly. And beyond the real-time update, we have to do query very well. In this version, we optimized the Doris Amazon Write storage engine. And we test it by using star schema benchmark. In this benchmark, we had 25% update on the fact table. And we find Doris is 25 times faster than ClickHouse in this scenario. The next one is variant. Variant is a feature that we introduced in Apache Doris on the second version of Apache Doris. It is really welcomed by many developers because it allowed users to save JSON directly into Apache Doris. And Apache Doris will extract the columns from the JSON document and save this field by using columnar format. And then using our storage engine, columnar storage engine to store it, it has a high compress ratio and very fast performance during analytics. In this version, we optimized variant performance. We can find in JSON benchmark, we get top one performance in code run scenario and the second position in hot run performance. We think code run is very important because many developers using JSON document as the observability storage. And in this scenario, many data is, I think it's code. So I think code run is very important. Besides variant to store JSON, and there are also some scenarios that user need to store JSON in a row format. In the past, user may store JSON as a string using string field in Apache Doris, and we introduced JSONB at 2.1 version, but not many users using it. Today, in this version, we optimize JSONB's performance, and we have tested these more than 20 APIs or SQL functions. We find almost all the function JSONB's performance is better than JSON. You can gain 5 to 10 times faster. So I can see you should migrate to JSONB from JSON. Another improvement is SQL cache. In the past, Doris user may use Redis as a cache. The user may query within the query to Apache Doris and save the result in Redis. And before query, they may look up the Redis and then to check if the cache is validated. And then if the cache is his, they may return the result directly. But if the data in Apache Doris change, the user or developer may not know that. So sometimes the result is wrong, but user has to accept the result. In this version, we introduce a SQL cache in Apache Doris. We save the cache result in backend node. When user send a query to Apache Doris, our query analyzer will check if the data has changed before after the cache, and then we will check if there are some non-deterministic functions in the SQL query. For example, the null function. If it fulfills, and then we will look up the cache and return the result directly. If not meets, we will send the full query to our backend and then gather the result from backend and return the result to the client. And also we have do some many works in our CPU planner. And here I illustrate the 4 very important ones. For example, the first one is partition proving. Many users store more than 30 years data in Apache Doris, and if we use day as a partition column, you may get more than 10,000 partitions. If you use hour as a partition column, you may get more partitions. So the partition proving performance is very important. In this version, we improve 10 times faster partition proving performance. We also do some optimizations on data school scenario. You can gain 5 times faster if you have data school problems in your data or in your circle. And another 2 important improvements is distributed aggregation or data trace. We gain 4 times or to 7 times faster. The last one is execution improvements. we do some executions on operators and the EXPRs or functions. For example, in operators, we improve the set operators performance by 30%, and we improve the sort operator performance by more than 117%. If the data is very large, you making more than 500% improvements. We also improve the partial group by operation. You making more than 200% improvements. For EXPRs or functions, we improve window functions performance by 10%, and for final function, we improve the performance by more than 300%. And also, especially I want to introduce the key swing improvements. Many BI tools may generate many key swing EXPRs. For example, I have seen a SQL with more than 100 key swing. We improve the key swings performance, especially for some SQL with very complex impression by more than 700%. The third one I want to introduce the functionalities we introduced in Apache Doris that make Doris more powerful. The first one is lakehouse. And in this version, we improved our availability on Iceberg and Apache PAM. We support REST catalog, branch tag availability, and the time travel, schema change, system table, or batch interval query, incremental query. We have integrated separate compute and storage architecture in version 3rd. After that, I found more than 300 enterprise has migrated from their old architecture to the composed storage and the compute architecture. In this version, we improved our cache persistence and LRU logic, and we also add warm-up mechanism into this architecture. And you can do separate read and write works by using different clusters. We improved meta service and the small I/O, especially for small I/O for S3. I think many users may bothered by small I/O when we write many small files on S3. In this version, we can optimize it. You can upgrade your old version to this 4th version. I think you may gain a lot. Nowadays, we find many developers, they will migrate their Hive data or Iceberg data or to Apache Doris because data is not very large. For example, only 100 terabytes. They do not want to maintain so difficult architecture. And also, many people are using Apache Doris and the lakehouse query engine. And in this scenario, they also need many complex queries or do ETL or ELT tasks on top of lakehouse. So in the past, if we run a very complex query in Apache Doris, you may get OM errors. So in this version, we introduced the spill to disk mechanism. Currently, we support hash aggregation order by, hash join, or CT operators. For example, let we take hash join as an example. During the hash table build stage, if memory is not very enough, we will split the hash table into many partitions into the disk with many files. And also during probe stage, we will load just one partition into memory. And during probe stage, if the probe data is in the partition, then it is probed regularly and return the result to the next operator. If the probe data is not in this partition, it will also spill to disk. And then after data is read finished, and we will read another partition from the disk and build hash table in memory, and also read another partition in the disk as a probe data to do probe. We test our spill disk feature by using TPDS 10 terabytes benchmark. In this benchmark, we use 16 cores and 64 gigabytes memory. We run the total 100 query about using 28,000 seconds. So I think it really works very well. For our observability scenario, we built an entire observability stack in data collecting tools. We support Filebeat, Logstash, Fluentbeat, and Kafka. And all these tools can collect data from your logs files or from Kafka or message queues into Apache Doris. And Apache Doris load performance is very well. And you can using SQL to query Apache Doris, and you can also using the existing virtualization tools, for example, Grafana, Log Discover, or Kibana. If you are using ELK as your log stack, I think you can try by moving to Apache Doris. Although many developers like variant data type, we find sometimes there are many sparse data in the JSON document. For example, in the JSON document, there may be 10 columns. The first 5 columns, all the rows has these cells, but in the last 5 columns, only part of the columns has data. If we see this sparse column as a separate column, or the metadata is very large, we will have a performance problem during query. So we have a sparse column mechanism. We can store all these sparse columns into a separate sparse column using binary codec. And after using that, the storage is reduced and the query performance is improved. As we know, many users are using Elasticsearch to store JSON and query JSON, but they do not want to Apache Doris to detect or detect the data and try to pass data or get the data as type. They want to define it by like Elasticsearch dynamic template. In this version, we introduced schema template. The user can define the pattern and the data type they want in the circle by when define variant data type. And after that, when loading data, Apache Doris will using this pattern to check the data's column name in the JSON document and try to using the data type the user provided in our schema. And also in this version, we have enhanced our geotype support. Currently, Doris supports geopoint, geocircle, geoline, geomultipolygon, and geopolygon. For example, we can use a simple query like this distance sphere to get the distance between Beijing and New York. And we also support many geo functions. I think it may be about 20 geo functions. I think you have a try. Finally, after I introduced Apache Doris' first version, we can find Apache Doris. It can do many things. First, it can do real-time analytics. You can synchronize your data from MySQL or PostgreSQL into Apache Doris and do analytics job. It is more than 10 times faster than your OLTP database. It also can do data warehousing tasks. You can do ELT or ETL jobs on top of Apache Doris, and it is also a lakehouse query engine. If you are using Presto or Impala to query Iceberg or Hive, you can have a try to Apache Doris. You may get more faster. And it is also an observability platform, can store many logs and metrics more efficiently. And finally, it has AI and search capability. It can do vector search for text search, and it can also do hybrid search. That's all. Thank you.